Okay, here's the review for the first test function forecast. It gives us the relation. It lists out those 5 ordered pairs. We want to state the domain and the range of the relation. Because this is discrete, it gives us specific points. We're going to have to list our domain and our range out discretely. So we'll have our domain. We're going to use our squiggly brackets or our braces. We're going to list out our x values from least to greatest. We have -6, 1, 3, -2, and -2. So we'll go -6, comma, -2. It repeats itself, so we're only going to write it once, comma, 1, comma, 3, and close our brace. Range is going to be the y values. So range will have 3, 5, 0, 1, 4. So we're going to go 0, comma 1, comma 3, comma 4, comma 5. Those are all my y values that I use. Determine whether it's a function and explain. Because our x value of -2 repeated, so we've got that -2 that shows up twice, this is not a function. So this is not a function because the x value of -2 repeats. On our mapping diagram, we're going to put one bubble that has our x values, our inputs, another that has our y values, or our outputs. Here we'll list our x values. We can just use our domain, -6, -2, 1, 3, and our range, 0, 1, 3, 4, 5. And we want to map. So if we look at our equations, our coordinate points it gives us, so it gives us the coordinate point -6, 3. So we're going to map -6 to 3. Then we have the point 1, 5, so we'll map 1 to 5. 3, 0, so 3 will go to 0. -2, 1, so -2 goes to 1, and then -2, 4. So again, you see that x value of -2 goes to 2 places. When we graph it, we're just going to graph our ordered pairs, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so we're going to graph our ordered pairs. So we'll graph -6, 3, put a point, 1, 5, put a point, 3, 0, put a point, -2, 1, put a point, and -2, 4, put a point. So again, you see that vertical line, a vertical line right here would intersect twice, still confirming it is not a function. So now we're going to move to problem number 2, which we worked on in class, but I'll still go through it again here. Our domain, we're looking the left to right. So the farthest left at any point my graph goes is -3. We also need to do it says to do an interval and set notation, which is, set notation is also called inequality notation, so I'm going to go ahead and write it again over here. We have an open circle there, which means we do not include -3, which means we're going to use a less than sign or a parenthesis if we're dealing with interval notation. Our domain is dealing with x. The farthest right our graph goes, so the highest x value we have is at +3. Again, it's an open circle, so we're going to use the less than sign or parenthesis. Okay, so these are 2 different ways of showing our domain. So we've got our inequality notation, where we have less than signs because of the open circle. In interval notation, we'll use parentheses because of the open circles. Going to range, we want low to high. The lowest we go is down here at -3. But here we have a closed dot, so we'll get a less than equal to sign. Range is y. When we do it in our interval notation, -3, again, because that closed dot, now we get to use a bracket, because that means it includes the y value of -3. The highest anything goes is up here at +4, but it's an open circle at +4, so we'll go back to our less than sign with +4, and then in interval we'll add the comma 4. Because it's an open circle, we're going to put our parenthesis in there. Deciding if this is a function or relation, if we look right here, a vertical line is going to cross my graph more than once. So it'll cross here and here. Anywhere between 0 and 1, our vertical lines overlap, so our x values are going to repeat. So this is going to be a relation, and our reasoning is x values repeat, or you can say a vertical line intersects more than once. Okay, so either x values repeat or a vertical line intersects more than once. On 3, we're looking at the distance a runner is covered in a marathon of 26 miles. We think about whether this is discrete or continuous. We're running a marathon. We're thinking about the time it takes to complete our marathon and the distance we've traveled. Both of those things would be continuous because we use all of the pieces in between. If we think about our domain, our x values would be time and our y values would be miles, or the distance we travel. We're running a marathon, so our time is going to be in hours. So a marathon is going to take anywhere between 0 when we start. So to finish my marathon, we start at no time. Finishing the marathon, again, this is appropriate, so it can be 4, 5, 6, 13, something of that nature. I'm going to put 5. When we look at the range is the miles we've traveled. So we're between 0 and 26 miles because that's how long my marathon is. On 4, we're looking at discrete or continuous for the number of coins in a wishing well. So if we look at our coins in the wishing well on any given day, so regardless of the day, just once a day we're going to look at the number of coins in there. It's always going to be a discrete number. It's going to be 7 coins or 15 coins or 18 coins. It's going to change, and it's not going to be all the stuff in between. We just look at once a day. So we're looking discrete. Because it's discrete, we need to list my domain and my range using our braces. We're just going to list them as a set. So the domain would be the days on any given day. So if we look at day 1 through day 7 of a week, that would be a 3, ... 7. You could do it through the year, so you could do it to 365, however you want to look at it. The range is the number of coins. We could have 0 coins, 1 coin, 2 coins, all the way up to however many coins you think would be appropriate. I'm going to put 500. You could have 100. You could have 50. It just depends on the wishing well. So something that's appropriate for the situation. Okay, looking at 5 and 6 now. 5 and 6 we're evaluating, so we want to plug these values in. So on 5a, we've got f of x equals 2x squared plus 1 for f of 6. So we're going to look at 2, but instead of x, we're going to have 6 squared plus 1. We need to do order of operations, so we do our exponent first. So we've got 2 times 36 plus 1, because 6 squared is 36. 2 times 36 is 72 plus 1 would give me my answer of 73. We plug in negative 2. We've got 2 times negative 2 squared plus 1. Negative 2 squared is going to be 4, because negative 2 times negative 2 is positive 4. Now we'll multiply. 2 times 4 is 8, plus 1 will give me my answer of 9. On 6, we're looking at absolute value now. So if we plug in negative 2, we've got the absolute value of 7 times negative 2 minus 5. Just kidding, pretend like that's a minus. 7 times negative 2 is negative 14 minus 5. Still looking at the absolute value of that. Negative 14 minus 5 is negative 19. The absolute value of negative 19, its distance from 0, is 19 units, so our answer is 19. On B, now we're plugging in 3, so the absolute value of 7 times 3 minus 5. This is the absolute value of 21 minus 5. 21 minus 5 is 16. The absolute value of 16, or how far 16 is away from 0, it's 16 units away, so our answer is just 16.